the first answer. What's the question? The question is, you have a system, how many entities you are recognizing from the system? How many entities you have in the system? The explanation, this was the homework.
4 entities.
Huh?
Departments, projects, supervisors.
Departments, projects, supervisors,
and employees.
and employees. Departments, supervisors, employees, and project. These are the entities that you can extract. So what was the common mistake? Many people wrote this employee department as an entity. This was a relationship, right? They added one entity as an employee department between here. They added the entity as employee project over here. Okay? And an entity between department and supervisor. Why don't we have such entities? When you draw an ERD, why don't you have such entities? Because they are by themselves, they are not explanative, they are not informative. They are just relationship between two entities, employee and department. So they don't have any abstract concept representing a specific information. So it's done. The other question. So we have this ERD diagram. How many tables do you draw? Which tables you need to draw? You need to create. One doctor, right? One patient, yes.
Free physician.
The other one?
One free physician.
This is free physician. Okay, so one is prescription and physician. Okay, the other one?
Pharmacy. Contract. Pharmaco.
So one is pharmacy, one is drug. Okay, one is a table showing sale of the drug. This should be also a table, right? Sale, which is relating pharmacy and drug, right? This relationship make. Do you need a table for this?
No.
No.
Why?
It's a weak
You don't
relationship.
have
What?
any attributes.
It has no attributes and also it's a weak relationship.
Okay, so you don't need a table for this one. For pharmacy company,
Table, it's an entity.
And
contract,
Table required.
next question. I mean, the homework is as easy as solving it in 5 minutes, isn't it? Like 5 minutes sure to at least answers the question. So you have these tables: department, employee, works, project. Okay, it's the first question. How many tables will be written by the following relationship? Salary, employee. Salary from employee.
5.
3.
3. Why?
Distinctive.
Distinguished. These are not. This is a relationship, not the table, so it doesn't have duplicate. So you have now. What is the result of the following? Then employee ID minus employee ID of the work. Employee ID of the employee. First of all, what this query asks, what this query presents in
List of
English
all
language.
employees who is not works.
Yes,
Not from work.
lazy employees, let's say. Okay, who is the lazy employee? Employee ID 101, 102, 103 to 105. 101, 102, 103, 102, 104. 105 is lazy, so it doesn't have any task. So what is the number of the tuples returned by this query? Department multiplied to employee multiplied to project. Each of them. Department 3. Employee 5. Project 4. 16. So write an algebraic expression returning the employees. What? How do you return the employees? Who work more than? How do you return the employees? You have to project just employees, right? So who work more than 10 hours on project 20? So how is it?
Select hours greater than 10.
Select
Hours greater than 10.
right.
And, product ID is equal to 20.
Equal, exactly. So that's it. So once simple select. So write a relation and algebra expression running employees. I'm sorry. Returning employees who work on all projects. On all projects. It's keyword all. It means that you need to have a division, right? You need to divide. So first you get the employees based on the employees, and then you get the employee ID of projects. So
Can you write it on the board for that one?
where is it? Where is it? Okay, so what are the project IDs? The whole project IDs?
10, 20, 30, 40.
These are the whole projects, right? This is the whole projects, okay? So for each person, where can I find which project he is working in works, right? So how many columns does it have? 2. How many columns does it have? 1. So this is what is the list of the projects? 10, 20, 30, 40. Do I have in the works, who is working for all the projects? Nobody, right? Obviously. The result is empty because each of the employees are missing at least one project. The result is empty, but this is what we can. Okay, so now this second part. Write a query to return 3 maximum salaries. How do you write a query with 3 maximum salaries? In SQL, in MySQL you have limit, right? In SQL Server you have top 3. Okay, you can use one of those. Okay, when you use top on a table, you return this 3. Okay, if you sort it descending, then you can get 3 maximum. Okay, so delete duplicated rows in employee table. What is the correct answer?
It already has primary key, so it will not
Yeah.
allow duplication.
You got an answer. The only person answered, I guess, I think that there are a couple of people. The correct answer was this. The employee ID is currently table. It's a relationship, right? It doesn't have any duplicate. It is a relationship, so it shouldn't have any duplicate. So, and
But there should be some query to write so that it should delete all the duplicates. But if you try to do that, it is asking the row ND something kind of thing, row IDs
but
and all.
the table has an employee ID, right? Sorry, primary key, right? The table has a primary key. If it has a primary key, it cannot have duplicate. There should be write something, but the answer should be. But whoever wrote the query, I gave complete
Actually,
credit.
like,
The query was semantically
we searched
correct,
in the net.
regardless of this point.
We searched in the net, they mentioned like this point actually. The proper query for this one will use the row IDs. When we tried that, it will be like this much query. So we didn't try that.
You can use the row ID and then delete the duplicated row ID out of this. So this is also, you can implement it as a minus also. You can implement it as a minus or implement it as a not in, and then you select distinct one, the first one, and then who is not in the selected distinct, who is in the selected distinct, not in the selected distinct, but in the selected query, it should be deleted. Right? You know what I'm saying? It should be, what should be deleted?
Duplication.
If you select distinct rows will be returned, okay? If you do not select distinct, usually rows will be returned. So select regular select minus select distinct will be those records that are duplicated, okay? Just delete them. Delete a star from, if you want to write it. If the table does not have any primary key, and possibly you can have records, so you can write select star from minus select distinct. What is it? Okay. Every DBMS has a row distinguisher here, so that you have row ID. So from employee, where row ID is in this, right? That's it. But the correct answer is employee table has a key, so it cannot be duplicated. So this department number and department name for all departments in which there are no employees in the department. So how do you write this? How do you write this?
Which one?
Third.
How do you solve this problem? Suppose that you have this problem. Jay, how do you solve this problem?
Nested queries.
So first of all, my method is that I want to list department number and department name for the departments which there are no employees. Suppose that first I will find departments they have employees. Okay? Find departments they have employees.
Select staff employee.
Select department ID from does it return? This returns all the department ID has some employees there, right? Department ID appeared in the employee. Okay? Now select star, let's say star from departments where if ID is not in or not in, is not in. Right? Is that correct?
We also need the department name.
So with the start, select start. Let's say everything. List the department number and department name for all departments in which there are. Okay. Find maximum salary from each department. This is easy, right?
Yeah.
So let's get all employee details from the employee table, order by name ascending and salary descending.
Order
Easy.
by name.
Again, number 6 is number 7 writing a trigger. Okay?
Yeah.
Write a trigger to keep the total salary of each department constant.
So, can you write some relational algebraic expression which uses order by or group by?
Which one?
No, order by.
Group by and order by aggregates. We haven't studied aggregates in the relational algebra. Aggregates, we haven't studied aggregate semantics today. And you know that aggregate is very complicated, not in relational algebra, but also in Prolog also.
I tried to write in my report, so that's why I just.
So, okay, basically, how do they represent aggregates? Basically, they assume that aggregates are always completed at the end. So, and then they represent the whole query without the aggregate functions, like without sum or without average. This is the whole expression for the relational algebra. They optimize that part, and then they try to compute the aggregate. And for aggregation, they have their own method of optimization. For maximum or for minimum, for average, all of them. Computation of also some of the DVM and some of the designers usually keep materialized view for aggregates. So the aggregate is always updated when some insert or delete happened. So they keep updated. So in order to make it faster. But aggregates are usually bottlenecks specifically for OLAP systems. So I want to write this trigger. Who wants to help me? Who wants to help me? Guys, I put a discussion on the blackboard. Nobody touched the discussion. Blackboard. On the canvas.
I mean, we discussed that in the class already.
Yes, but I was expecting some people contribute to the discussion. But it was good, so. Okay, so write a trigger.
Create trigger.
figure name on table.
On which table? Total salary of each
Employee table, we have salary.
On employee.
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 On employee.
So employee. Okay, so based on it should be
Before-
transactional
Instead of
after what? After update or
update or insert.
insert or delete also?
Update.
After so it should be based on row or transaction
For each row.
for each row or for each row?
Each row.
Should be for each row or
It should be for each row.
no? No, for each, not for each. Why do we say that it should be for each row? Can I bring an example that I'm changing in each row? I can change two rows, but the total of the department is getting still constant, right? I decrease your salary and increase my salary. So it can be so for each
For
transaction, right?
each row.
Okay, old and new.
Update this.
Should I follow the? Should I follow the? Let's say.
Old rows.
Where? So now it's time for writing what? Condition, right? If or where? If what?
Condition.
What condition? I know what.
If the
How do you understand? How do you realize that the total is different?
Can you see the question?
you have to check the total before the update and after that it will compare it.
Exactly. So you have to check. So suppose that how do we represent in standard SQL the old and new as we call as, right? Say that old as old, new as, and okay. So then, okay, what? It's getting larger. I'm using this part of the blackboard, right? If
Sum of salary. Sum of salary.
if sum of salaries group by
Department ID.
Department ID.
okay, this is Okay, this is the first part. If this is completed, so how do we know that this is changed? This is the new one. This is the old one.
Sun is great.
Okay, there are two queries. One is here, one is here. If I do minus, what does it mean? It means that something is changed, right? If the minus is not empty, it means that something was changed. So if I put exist over here, solve, right? Then begin, roll back transactions, right? That's it.
Yeah.
So wasn't easy. So
Now
Now
itself
it
it
is
is
easy
more
because
complicated,
before-
Professor. It's
Why?
looking more complex now itself. At that time it's like
We
Yeah.
it's something
we
else
didn't know
actually.
anything about triggers then.
okay, I guess because you wrote the answer, right?
Yeah,
You
yeah.
know what?
Only this and others.
Professor, is it possible to write update, insert and delete on in a single trigger?
Hmm?
Like one trigger is only for update, either for update or insert,
You know,
right?
you can put
Multiple?
all the transactions. Update, insert,
In
delete.
single trigger?
Yeah, if you change, you are considering all of the changes, you can write it. You can write all of them. Even in SQL Server, you can write it, right? We did it in SQL Server.
No, when I searched, I didn't find that. Like,
In SQL Server, it's an error.
yeah.
So probably in SQL Server, but in standard trigger in SQL, you can write it.
Okay.
Professor, using after is not a good practice, right? I mean, if you have a large
Yes.
number of tables, then
Using after is not good practice.
So before update is.
Before update, but here cannot.
You cannot do before update.
You cannot do it before update. You have to get the new.
No, like we can get
You have to complete it.
we can get the new value and compute that.
Okay, more questions? One more, the last question. What is the last question? Write a trigger to make sure that updating employee is assigned to a project does not leave the employee without the project without employee. So what does it mean? How? So which table?
At least
should-
one person should be in a project. One employee should be in a project.
Project and works.
Works.
Okay. On what?
Works.
date.
For each. For each row or for each? For each row.
For each transaction.
Transaction.
Because,
If I remove update, you could write it for each row, right?
yeah.
But if when you have update, you have to have it for each transaction. So, from implementation point of view, if you were working in a company, would you do the same thing, write both of the cases in the one query, or you divide it in delete and update?
It is better to divide it.
Why? Because the cost of trigger on each row is much less than the cost of on each transaction. Because when you are putting a cost on the transaction, then the rollback should be happen on the transaction, and a very big log should be kept. Okay. Okay. If what happens when some project is without employee, we have a
The project IDs will not be.
select project ID from
Project
Project.
and works.
project.
Works.
So these are all the projects, minus select from
Works.
if something is existing, then it exists something here, and what you should do, begin rollback transactions, right?
Instead of minus, can we write a query where we are checking project ID is equal to project ID?
Yeah, you can write it. You can also write it. That is smarter but difficult. For me, it was easier. Okay, so should I go through the rest of the homework assignments we had? How can I see this? Do you know how I can? Okay, we have a preview. So, what is the answer for this question? Very fast. Jit, what is the answer for this question? Hmm? Ready? Did bother you discuss about this?
The question is not visible.
Oh, the question is not visible?
That's what I'm looking at.
But hmm?
Salus dot ID something. Sweetings. Salus dot ID something else.
I don't get it. Problem. What did you say? What did you say?
Salus dot ID something which word which.
No.
Some Salus.
It's a very simple.
Yeah, simple expression which we need to improve.
Right. Let's just answer this question, Bahadur. Shashidhar, you want to join the discussion? You want? So what is the condition? Mufika, what is the condition?
Anyone can answer this. I mean, we have to combine department and department name and the department.
Employees.
So
Employees
Salaries.
which tables are salaries?
Department and
Which department should be joined?
Departments and department employees.
Department employee, right? So which tables are left from the joint?
Departments.
Departments and department employees.
Department and department employee. So department ID is equal to department employee, department ID. So this is.
Their department.
You were saying salaries, and I was realized why salaries. Consider the employee department database. We had the class and the relative functions like this. So this function calculus. Okay. Submit. Okay, so question, what is the question? Okay, consider the following query which returns the last name of an employee from the development department who has not seen any changes in her salaries for the longest time. Okay, so it's very interesting query. So we need to put the condition over here. What is the condition? This expression.
Same that max diff date we have to put it there.
Which the max date is the maximum, right?
Yeah.
So whose max date should be this one? Employee. In which table? In salaries. It should be salaries dot employee ID. No, it should be salary.
No problem.
No,
Just
no.
max.
It should be dative between
Between
the
starting date and
starting date and end date of the salary. Exactly. It should be the dative between start date and last date of the person. Okay? Well, so the next question, this is the next question. Suppose that you want to write a simple query to find the employee number of all of the guys that are paid more than average of ladies today. Okay? So how do you compute this? You are supposed to find average of ladies first. One subquery, you have to write for to find average of ladies. How do you understand that who is lady?
The gender.
Gender
By
employee.
table and
Right?
we just have to combine employees and salaries.
Salaries. Nothing else is involved. The previous problem. Suppose that you want to write a simple query to find the
Same, two tables.
because for all of the queries I'm calling it simple query, and I'm sure that some of the queries are not simple. Suppose that you want to write a not simple query to find the employee number of all the guys that are paid. Okay, the same. If you use subquery to answer this question, how many tables do you need to?
Two tables.
Two tables. Again, nothing can change. Okay, so which of the following tables are not required to calculate the average current salaries of ladies?
I mean, we'll have two answers for this process because we can remove either titles or either department manager. That's not a problem. So
Yeah, we can write
conflict also like the answers. I mean, like we can write with titles or department in both.
both. We can use either of the titles or department manager.
you know that it's not possible. I showed you why, right? I showed you.
But
There may be,
no,
the title
what
may
you said
be
is
manager.
that, this is the efficient way. You said that this is the efficient way to find out.
No, but I didn't say efficiently. You can find ladies that the title is manager, but they're not managing any department, right?
That has ever served. I mean, that's it. Right?
Oh, I was can interpret.
That have ever served as a.
That's why.
They did not
It
say
was-
now.
If I mention the department and I the department, then it doesn't say anything. So what is the last one? In order to calculate the average of the current salary of the people who have ever worked as a staff, which of the following set of tables are required in the query?
Employees titles.
Employees' titles,
Salaries.
salaries, just 3. And submit the quiz. Okay. Find the shipping address of all the people whose title is Miss. How? It's really simple. It's a simple join, isn't it? Join between person and
No, Professor. This is not a simple query, Professor. For this, you have to find out the shipping address based on. Like we have to join some four tables, Professor, for this one. This is not a simple query.
4 tables. Joining 4
No,
tables.
not 4 tables. Even more, I think. So like first you should have to analyze all the tables, and then you have to find out what is the shipping address code, and then what is the address code assigned for that particular person, and then you have to join. Like you should analyze all the tables in that thing.
It's 3 joins.
No, not 3, Professor. You should check it out. I forgot.
Let's
It's
see.
long back, so.
Where is the shipping address?
It's not directly there, Professor. We have to.
No, I know it. There is a separate table. Where is the shipping address? Address type. The address type is returning what type of the address it is, right?
Yeah.
Billing address. Yes, shipping address. Okay. The address type ID should be 5. Okay. Then the person address. The person address has an address ID, the name of the address, and then
4 tables. We have to use 4 tables, Professor. Person, business entity address, then
so you need this address also. You need
and
the
then
address table.
type.
Where is this guy person?
3 from person dot person. Okay.
The title is here.
From
Okay.
person. Address type. 4 tables.
4 tables are there.
4 tables, Professor.
Right.
Person, business entity address, and then address type.
Where is the business entity address? Okay, yes.
Yeah.
4 tables. Just join. Business entity, address ID, address type. Address type. You have to.
Shipping address is 5 for address.
Right. 5. Yeah.
But we should not
But we
hard
should
code
not
that,
write-
so we
You
have
should
to write a
have to have
subquery
4
for
tables.
that.
Yeah. Right.
So
That's 4
we should write a subquery.
Subquery.
4 tables. That's okay. The class is over, so we will continue on.